Assalamualaikum warahmatullahi wabarakatuh. My name is Sharir. I will be starting the presentation for our group team. Um, and later on, I will finish with some discussion and conclusions. Allow me to continue with the introduction of our project. So our project name is called Improve DFA Model for Healthcare Vending Machine. So basically, we are trying to use DFA, deterministic finite automata theory, to model and improve the operational logic of healthcare vending machines. Why DFA? The name speaks for itself. It ensures correctness, determinism, and robust error handling. The project aims to bridge theoretical concepts with practical application in automated medical dispensing, emphasizing the importance of structured state transitions and reliable user input validation. And part of the rubric, we should not use any kind of AI or machine learning because the focus is on understanding the theoretical of computer science in this application. A bit of motivation background. Healthcare vending machines are increasingly vital in environments where we need human contact to be minimized, such as hospital and clinics. So this machine automate the dispensing of medical product. For this example is eye product and also vitamin. So the automation ensures transitions, reliability, and reduce errors, which is critical in medical context. We don't want to prescribe wrong medicine to the patient. And the use of DFA is particularly suitable because it provides a structured, predictable framework for modeling transition flows, ensuring that every user actions leads to the well-defined system response. By leveraging DFA, the vending machine can validate user inputs, enforce correct operational sequences, and prevent invalid transitions, thereby enhancing safety and efficiency in healthcare settings. All right, I will let my next team member to present. The floor is yours, Mr. Carol.
Hi everyone. For my part, I focus on the literature review and the shortcomings of an existing DFA model for a healthcare product vending machine. The paper basically uses a deterministic finite automation to control a simple dispenser flow, which is insert money, reach a total required, select a product, dispense, and then reset. In the next slides, I'll quickly link this to DFA and regular language basics, summarize the original DFA model, and then point out what's missing if we want it to be realistic in an actual medical dispenser environment. So just a quick recap. A DFA is defined as a 5-tuple states Q, alphabet sigma, transition function delta, start state Q0, and accepting states F. So the idea is determinism. For every state and input symbol, there is exactly one next state. A string is accepted if, after reading the full input, the machine ends in an accepting state. In theory, DFA languages are regular languages, meaning they can also be described by regular expressions. For vending style systems, states usually represent stages of the transaction, and symbols represent actions like inserting money or pressing a product button. So in the paper's model, the machine dispenses two items: eye drops, labeled as E, and vitamin C, labeled as V. It only accepts RM5, RM10, and RM20. The DFA states are basically the running total. Q0 means RM0, then Q1 is RM5, Q2 is RM10, and so on up to Q10, which is RM50. The start state is Q0. The accepting states are the states where you have enough money to buy something from RM35 and above in their table. Once you reach an eligible amount, pressing E dispenses eye drops, and pressing V dispenses vitamin C, and then the system returns to Q0. So now for the shortcomings, which is in the next slide. So first, the model isn't fully complete as a DFA because some invalid actions are just left blank instead of transitioning to an error or sync state. For example, selecting vitamin C before reaching RM50 or inserting unsupported input. Second, the payment rule is a bit ambiguous. The text mentions exact change, but the model also allows amounts equals to or exceeding a price, and it doesn't define what happens if users deposit beyond the maximum state they listed. Third, it ignores practical features like cancel and refund, timeouts, and handing over payment or making change. And because it's healthcare related, a real dispenser should also model stock status, expired items, safety constraints, and audit logging. So overall, it's a good learning DFA example, but it's simplified and not yet ready for real deployment. Thank you.
My name is Kale. I'm going to present methodology and implementation. For the slide 1, enhanced state structure. This slide, the enhanced state structure of the DFA model used in the healthcare vending system. Each state represents the specific stage of the transaction, and starting from the idle until the transaction is completed. For the dead state is included handle invalid input and prevent system errors. Additionally, the simplify the input symbols and translation improve the clarify efficiency and scalability of the system. Thank you. For the next slide, I move with the transaction flow and error handling. This slide I explain how the system manages the transaction flow and error handling. The system requires a payment before product selection and make sure a valid and secure transaction process. If invalid input occur, the system moves into the dead state. Maintain system integrity. The model also supports and cancellation functions, allow users for the returns the idle state and request refunds. Basically, the deterministic translation ensure every input leads to clear and predictable next state. Thank you. I move with the third slide, valid and invalid input sequence. This slide highlights how the system differentiates between valid and invalid input the sequence. Valid transaction follow the correct order, which start with the payment and ends with the product dispensing. The system also handles the overpayment by allowing the reset and refund options. Meanwhile, invalid sequence as selecting a product before payment are automatically redirected to the dead state. For the DFA model, ensure the strict input validation and reliable system performance. Thank you.
Assalamualaikum and hi again. I will continue my slide deck on the result and discussion, and later I will conclude it. So now we are at the model limitations and advantages. So I will try to explain, discuss, and what kind of improvement we can do to the original DFA. We know the original DFA lacks comprehensive error handling and product identification, and we know we want to create an improved model that have a clearer stages, so that we can offer a better robustness, scalability, and operation clarity. Importantly, the enhancement must be within the scope of DFA theory. We cannot use machine learning, and we try to focus on the automata principles in order to improve the vendor machine for healthcare. So allow me to do a little bit different. I want to use some GUI that we program in order to bring up the idea. That's the purpose. So let me change the slide into the GUI. So as you can see in the screen, so this GUI basically trying to explain the original DFA first, and later we will introduce the improved one. So basically in the original DFA is a changing state each time we adding money to it, right? And then finally it will reach to a certain state, a final state at Q7, Q8, Q9, and Q10, where if anyone buy eye drop of vitamin, the DFA will reset back, right? So this kind of DFA is what proposed in the paper. So our proposed solution is first to use a two-line DFA. So because we know from the paper, we critique the paper that the current DFA lack of product identifications. So after we reach at more than 35 ringgit, there's no way to tell whether this is about the eye drop or vitamin. User wondering
they're feeding money, but they're not sure whether how much money they need to add in order to reach a certain value. So basically, in the Tulang DFA, we need to choose either eye drop or vitamin. So for example, here I choose eye drop, then we add the money and it's changing state to the point that it reach the total value of 35 ringgit, and that is the final state, right? And even though I try to click vitamin, it will not purchase it because it was in the different path. So after clicking for the eye drop, the system reset, and if I add money again, if I choose the vitamin path and I add money again and again to the point that it reached total value of 50 ringgit, and I choose vitamin, now it will dispense for vitamin and then the system reset again. So it is a kind of a more simplified version compared to DFA, because this allow for the product to be identified. And finally, our proposed solutions, our improvement to the existing DFA system is by using non-deterministic automata. So basically, in non-deterministic, we can add money, right? 5, 20, or to the point that it will reach certain value that equal to the value of the eye drop, so that allowing it to be chosen. Even though we add money 5 ringgit, we still not able to purchase for vitamin, but at the end of the states where it reach finally at 50 ringgit, we are offered with two choices, right? Still we can buy the eye drop or we can buy the vitamin. So compared to the other method just now, right? So if you there in the DFA with the multi lines, if you already choose the line for the eye drop, you cannot switch to the vitamin until we choose it. We ensure that the value reach the final state, right? But in this case, it still allow the selection between product. At the same time, it promote a more simplified version of the diagram, right? So I hope by using these examples, it make easy for the audience to understand the improvement that we try to propose, right? So let me return back to the slides. Okay, in the slides, our conclusion is the improved DFA model effectively addresses the requirement for reliable healthcare vending machine operation. It provides structured transaction flow, robust error handling, and clear input validation. The key improvement include introduction of item-specific states and explicit error management. This enhance user trust and system reliability. And in our future work, if we want to expand the DFA, we can add more products, additional product, and denomination while maintaining a minimized state structure. That's the aim. So this enhancement will further strengthen the practical applicability of DFA in automated medical system. So I hope by concluding this, we also have critically analyze the paper and also propose our improvement for the future states. Thank you very much.